Namaste everyone. I am Disha, an electronics and communication student at Sri Venkateshwara College of Engineering. I am here to give a presentation on Gram Schmidt orthogonalization. First and foremost, what is Gram Schmidt orthogonalization? It is a procedure or process that takes a set of linearly independent functions or vectors and constructs an orthogonal or orthonormal basis over an interval with respect to a weighting function or an inner product. Moving on to the next slide. Let us discuss a problem using Gram-Schmidt orthogonalization. And in the above displayed question, they have given four signals, that is S1 of t, S2 of t, S3 of t and S4 of t. The sub-questions are: find the number of basis functions is required to represent the given four signal, and the other sub-question is find orthonormal basis functions, that is phi 1 of t, phi 2 of t, phi 3 of t and phi 4 of t. As the given signals are S1 of t, S2 of t, S3 of t and S4 of t, so the number of signals are 4. I am considering m is equals to 4 and n is not given in the question. We know that n should be less than or equal to m. So I am considering the maximum value for n is equals to 4. In step 1, we have to find the first basis function, which is phi 1 of t, and to find phi 1 of t there is a formula, that is s1 of t by root e1. And how to find the e1? E1 is the energy of the first signal, that is s1 signal. So e1 is equals to integral from the limit 0 to t of s1 of t into dt. In my question, there is an interval, the interval of the s1 of t is from 0 to t by 3. So I am considering interval 0 to t by 3 and amplitude is 1. Okay. By integrating this signal, I am getting t by 3 joules, which is the value for E1. We know that S1 of t is equals to root E1 into phi 1 of t. By taking E1 of t to the LHS side, I am able to find out what is phi 1 of t. Okay, phi 1 of t is equals to S1 of t by root E1. Substituting E1 signal, which I obtained here, in this equation, I am getting phi 1 of t is equals to root 3 by t into S1 of t, and multiplying the root 3 by t for my S1 of t in the question, the signal is given. So I am getting phi 1 of t, and here is the spectrum or the waveform for phi 1 of t, and in terms of values I have written here phi 1 of t is equals to root 3 by t at the interval 0 to t by 3 and 0 for the other values. Step 2. To find other basis function, let us consider the generalized equation which is given over here, that is gi of t is equals to si of t minus summation from the interval j is equals to 1 to I minus 1 sij phi j of t. I am considering I is equals to 2. Substituting I is equals to 2 in this equation, I am getting the equation like this, and slight changes. It is 1, not 2, and the summation interval is from j is equals to 1 to 1 because 2 minus 1 is 1 again. We know the formula to find the S21, that is S21 is equals to interval from integral from 0 to t S2 of t into phi 1 of t into dt. By solving this integral, I am getting the value which is 2 into root of 3 by t into t by 3, and further simplifying this, I am getting as, after the further simplification, I am getting S21 is equals to 2 root t by 3, and substituting this value in the generalized equation, I am getting g2 of t is equals to s2 of t minus 2 root t by 3 into phi 1 of t. Phi 1 of t is already obtained in the previous slide, and s2 of t, the signal is given in the question. So plot of g2 of t is the signal 2 root t by 3 into phi 1 of t is subtracted from signal s2 of t, as we did the subtraction over here. This is the g2 of t, as you guys see here, and finding the energy of the signal 2, that is eg2 of t. The formula is integral from the interval 0 to t g2 of t whole square into dt, and the amplitude of g2 of t is 1. 1 square is again 1. Integrating this, I am getting Eg2 of t as t by 3 joules. In the last slide, we have calculated the value for Eg2 of t, and we know the formula for phi 2 of t. Phi 2 of t is equals to g2 of t. It is the generalized equation, and divided by root of energy signal of the second signal, and substituting Eg2 of t as root t by 3, I am getting root 3 by t into g2 of t, and multiplying the signal g2 of t by root 3 by t, only the amplitude changes and the time intervals remain same, and phi 2 of t is root 3 by t at the interval t by 3 to 2t by 3, and 0 for the other time intervals. And you should note this, E phi 2 of t is equals to integral from interval t by 3 to 2t by 3 phi 2 of t square into dt, which where I am substituting the value of phi 2 of t where I have obtained here, that is root 3 by t, and integrating this and applying the limits, I am getting the final answer as 1. 1 which is orthonormal because it is a constant and it is 1. For if I get any other constant, it would have been orthogonal, but I am getting here 1, so it is orthonormal signal. The second important point is no overlap between signal phi 1 of t and phi 2 of t, so it is orthogonal, and to satisfy the condition for orthogonal, the integration of the product of phi1 of t and phi2 of t should be 0, which the statement is true in this case. And for getting the third basis function in the general equation, I is substituted as 3. And after substituting I is equals to 3, I am solving the equation. And I don't know the value for S31 and S32. So finding S31 formula to find is integral from 0 to t S3 of t into phi1 of t. After solving this equation, I am getting S31 as 0. Similar way, I am solving for the S32. Phi2 of t we have solved. Multiplying these two equations, I am getting root 3 by t at the interval t by 3 to 2t by 3. And integrating the product of this signal, I am getting S32 as root of t by 3. And substituting the values of S31 and S32 in the generalized equation for I is equals to 3, I am getting this equation, that is G3 of t is equals to S3 of t minus root t by 3 into phi2 of t. As in the previous signals, I am finding the G3 signal by subtracting these two signals, and as I did to find the energy of the second signal, in the similar way I am doing to the third signal also. So I have got the energy as T by 3 after solving that. And for the previous signals, how I found the phi 3 of t in the same phi 2 of t, in the same way I am finding the phi 3 of t also. So I am getting phi 3 of t is equals to root 3 by t at the interval t 2t by 3 to the t and 0 for the other signals. Again, there is no overlapping between phi1 of t, phi2 of t and phi3 of t as we see in the signals here. And step 4 is to find the fourth basis function, which where I am going to apply or substitute I is equals to 4 in the general equation. After solving this general equation, I am getting G4 of t is equals to S4 of t minus S41 phi1 of t minus S42 phi2 of t minus S43 phi3 of t. In this equation, only S4 of t is given in the question. So I have to find S41, S42 and S43. In the same way where I found the S31 and S32, in the same way I am finding the S41. S41 is integral of S4 of t into phi1 of t. I am getting the signal. S41 is equals to root t by 3. In the same way I am finding S42. I am getting S42 as root t by 3. Similarly for S43 I am solving. I am getting as root t by 3. Substituting S41, S42, S43 in the general equation where I substituted I is equals to 3. I am substituting in that equation. Obtaining G3 signal by substituting these signals in the general equation, I have got G3 of t is 0. And similarly G4 of t is 0 because phi 4 of t is 0. And these are the important points to be noted. Number of orthonormal basis function is equal to 3, that is n is equals to 3, which is less than m. They are phi 1 of t, phi 2 of t, phi 3 of t. And the second point is, if we observe the signals S4 of t, S1 of t and S3 of t, we can say S4 of t is the product of S1 of t and S3 of t. So we can say that the signal S4 of t is linearly dependent signal. The number of orthogonal basis function is equal to number of independent message signals. Representing all the four signal in the terms of basis function, and first signal is S1 of t, which is S1 of t is equals to phi 1 of t into root t by 3, which I have represented here in the waveform or the signal form. And going to the second signal, that is S2 of t. S2 of t is equals to root t by 3 into phi 1 of t plus root t by 3 into phi 2 of t. This is the signal form. And by considering the third signal, that is S3 of t, S3 of t is equals to root t by 3 into phi 2 of t plus root t by 3 into phi 3 of t. Considering the fourth signal, that is S4 of t, S4 of t is equals to S1 of t plus S3 of t, and we can also consider root t by 3 into phi 1 of t plus root t by 3 into phi 2 of t plus root t by 3 into phi 3 of t, and this equation, the below equation, is in the form of or in the terms of basis function, that is phi 1 of t, phi 2 of t, phi 3 of t. And here ends my problem. Hey guys, thank you for watching the video. Please like, share and subscribe.